I have been urged to say the following. If you happen to like the excerpts you've seen so far, please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.
The ambiguous case of the sine rule is what we're going to do now. Hope I spelled that right. No, I haven't. Ambiguous case of the sine rule. Right. So let's draw a diagram. And given a line of length 12 centimeters, whatever, which we'll call BA, and this angle here of 32 degrees. The third side of this triangle, which we'll call AC, C will be a point along this line here, and AC will be 7 centimeters long. There'll be two possibilities here. One, if you try to do this with a compass, you get the compass pencil would cut there and also at another point there. So in fact we have two triangles, not one. Just to distinguish between the two C's, we'll call this one C1 and that fellow C2. Right, so let's see what the angle by the C1 or C2 is going to be, and for that we use the sine rule, which is just now sine C over the side opposite that, which is 12, equals sine 32 divided by the length of the side opposite that, which is 7. This will give us C equal to inverse sine 12 sine 32 divided by 7, which on the calculator, when we punch it out, will come to 65.3 degrees. Or there's another possibility, is that it will come to 114.7 degrees. Because the sine of both of these angles is the same. If two angles add up to 180 degrees, like for example 100 degrees, 80 degrees, the sine of both of those angles will be equal. And this is where the ambiguity rises. So this is obviously the acute angle. We can now label that fella as 65.3 degrees, and this chappy here as 114.7 degrees. Our next step then, or the final step, is to work out what the length of the third side is. And there's two possibilities, B to C1 or B to C2. Okay? And that shouldn't be too difficult. So, if we look at triangle ABC1, the angle A will equal, so we're talking this triangle here, it'll be 180 minus this one minus that one. 180 minus 32 and minus 114.7. which will come to 33.3 degrees. So this little bit here is 33.3 degrees. So we now apply the sine rule to work out this bit here. Okay, B to C1. And B to C1, that's applying the sine rule, will be 7 sine 33.3 divided by sine of 32, which comes to 7.25 centimeters. And lastly, to get, excuse me, to get B to C2, we'll use the next triangle, triangle ABC2. And in this case, angle A is 180 minus 32 minus 65.3, which happens to come out to 82.7 degrees. So referring back to our little picture, the whole of that angle there is 82.7 degrees. Okay, so this is the triangle we're looking at, and we want to work out B to C2. It's a straight application of the sine rule. B to C2 will equal 7 sine 82.7 sine 82.7 divided by sine of 32, which comes to 13.1 centimeters. That does it.
Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.